Hi, in this video we are going to talk about finding standard deviation. The one that we're going to be focusing on is something called sample standard deviation. It's a measure of dispersion that allows you to how spread out data items in the data set are going to be. So here's the procedure we're going to follow. First we find the mean, then we're going to find what's called the deviation, that's the difference between the data item and the mean. After that we're going to square each one of those. We're going to add all the squared deviations. Then we're going to divide the sum by the number of items minus 1, and we take the square root of that result. Okay. Please keep in mind that when you subtract data items minus the mean, if the data item is less than the mean, some of these results will be negative, but when you square it, everything has to be positive. And this is the formula for finding sample standard deviation. Sigma means the summation, or adding together the squares of data items minus the mean, all of them, and we divide it by n minus 1, and we take the square root. So let's go ahead and take a look at some problems. So here's the set. Okay, I'm not going to go through the process of finding the mean. The mean for this set is going to be 9. We have these 6 items. So deviation is going to be 5 minus 9, which is negative 4. It's going to be 7 minus 9, which is negative 2. 8 minus 9, that's negative 1. 9 minus 9 going to give us 0. 12 minus 9 is going to give us 3. And 13 minus 9 is 4. So each one of these numbers will be squared. So negative 4 squared is 16. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 3 squared is 9. And 4 squared is 16. Adding all these together will give you 46. You can check the math. So we're going to divide it now by n minus 1. So in our case, n is 6. So we're dividing 46 by 6 minus 1, which is 46 over 5. You can divide that, but it's not really that important. You need to do the square root of that number. So square root of 46 divided by 5. And when you divide it, you're going to get approximately 3.033. Alright? So let's go through this one more time. We'll find the mean. It's easier to do it in the table form. So when we put all our data items in the table, we're going to subtract the data item minus the mean. That's how we got all these numbers. Then we take each one of these numbers and we square them. Please remember, every result here is going to be positive. Add them together, divide by the number of items minus 1, which is this number, and finally take the square root. Okay, so that's the process. Let's go ahead and take a look at the next example. The next example, we have these items. The mean here is going to be 65. And now we're going to go ahead and do the same thing. 45 minus 65, that's negative 20. 47 minus 65, which is negative 18. 68 minus 65, which is 3. 70 minus 65, that's 5. 71 minus 65, that is 6. And 89 minus 65, which is 24. Okay, squaring each of those values. Negative 20 squared is 400. Negative 18 squared is 324. 3 squared is 9. 5 squared is 25. 6 squared is 36. And 24 squared is 576. All these added together will give 1370. So we divide this, we also have 6 items here, so we're going to divide by n minus 1, so 1370 divided by 6 minus 1, which is 1370 divided by 5, and finally the square root of that number is going to be 16.553, etc. Okay, so here's what we need to understand. If you remember the previous problem, our standard deviation was just a little over 3, and in this case we have a standard deviation of 16.5 roughly. So these numbers are going to be more spread out from the mean than the problems in the in this example, in example 1. Okay, so that's what it tells you. Alright, so what we're gonna do now is I'm gonna show you how to do this on the calculator. I'm gonna use TI-84. So here's the process, because the sets get longer and gets more complicated. Alright, so we're gonna go press Stat button. We're gonna go to Edit. We're gonna enter our data items. 45, enter, 47, enter, 68, enter, 70, enter, 71, enter, and 89, enter. So we got our 6 items. After that we're going to exit here. We're gonna press the Stat button again. No, I'm sorry, we're gonna press second stat. Yeah, second stat. We're gonna go to Math. And in Math, option number 7 is standard deviation. So we select that. And then we're gonna need to enter our list. I entered that into L1. So I'm gonna do second one, which is L1, close parentheses. And there is our answer. So of course, if a well, first it's fairly tedious process calculating standard deviation, and as you get more and more items in the data set, it gets even more tedious. So even with 6 it's not too bad, but imagine if you have a set of 20 items. So doing this by hand can get a pretty time-consuming process. So I am going to do it for the other sets with a calculator from this point on. You can always look online how to find the standard deviation on a particular calculator. Alright, so here's what we want to do. Here we have these two math classes, 10 students each. Students took the same exam, got the following scores, and then what we want to do is find out what the mean is for each class and what the standard deviation and how we can interpret that, because of course we want to understand the standard deviation, how it can be interpreted. Right. So here's what I'm going to do. I'm going to go to Stat, Edit. I'm going to enter my new values. So 65, 68, 68, 71, 75, 78, 80, 85, 92, and 98. Okay, so got that, and I'm going to come over here. This is L3, and I'm going to enter my numbers for the second class: 70, 71, 73, 75, 77, 79, 82, 82, 83, and 88. Okay, so we're going to exit this. And what I want to do now is I want to find the mean and the standard deviation for each set. So here's what I'm going to do. I'm going to do second stat. I'm going to go to Math. And the first thing that I'll do is I'll find the mean, which is option 3, for the first set, which was class A. I got 78. Okay. Then I'm going to repeat that process. I'm going to do second stat, go to Math, mean, option 3, and I'm going to do it for L3, which was my other list, and I got 78. So it looks like both classes on average did equally well. So is that actually the case? Well, let's find the standard deviation. So we're going to do second stat, we're going to go to math, and we're going to use option 7 for standard deviation. And I'm going to do it for class A, which is list 1. And I got 10.9. I'm just going to round it to one decimal place, 10.9. Okay. Now let's go ahead and do the same thing for class B. So we're going to go to second stat, go to math, option 7, standard deviation. Oh, I'm sorry, I forgot to do what I needed to do. Forgot to specify what list I want to use. And I'm going to use list L3. And I got 5.8. So half roughly. Alright. So what does it tell you? Since we have data that is numbers are relatively close because they mean the same thing, not like examples 1 and 2 where you have completely different numbers. These are grades and we can interpret them and understand them better, but this tells us that class B has numbers that are closer, which means the abilities of students in class B are more uniform than the abilities of students in class A. So class A has more variety of abilities than class B. So what does it mean to a teacher? If a teacher teaches these two classes, it is going to be somewhat easier to teach class B since they have more uniform abilities as opposed to class A. If you look at this, you see class A, you have one student who scored 98 and you have one student who scores 65. So the spread of grades, not just the spread but also the standard deviation, is higher. Okay, as opposed to class B where the abilities are more uniform. All right. And we have a couple more. Well, just one more example that I want to show you is something about standard deviation. And this, I'm going to take this set here. I'm going to go back to stat, edit. I'm going to clear this set. And I'm going to clear this set. And I'm just going to enter these 5 numbers. So 12, 15, 19, 20, and 24. This is just something that I want to show you about this that I think you should know. I'm going to exit this. I'm going to go to second stat, math, standard mean. Mean is going to be option 3 of list 1. And my mean is 18. Right? And I'm going to find the standard deviation here. So back to second stat, math, option 7 for standard deviation, and list 1. And my standard deviation here is about 4.64. Right? So what we do now, we want to increase all the numbers by 500. So the numbers increased by 500 will be 512, 515, 519, 520, 524. So let's see how it's going to impact the mean and the standard deviation. So what I'm going to do is I'm going to go back here, press stat, go to edit, and rewrite all these numbers. So 512, 515, 519, 520, and 524. Okay, exit this. Second stat, let's find the mean first, which is option 3 for list 1. And I got 518. So you can probably see that the mean increased by 500 as well. Right? go ahead and find the standard deviation. Go to second stat, math, option 7, list 1, but my standard deviation remained the same, 4.64. So what did we notice? While the mean increased by 500 as well, the standard deviation remained the same. Remain the same. Okay, because remember, the standard deviation shows how spread out the values are, and since you only increased everything by 500 but they remained to be just spread out as they were before, then that's why the standard deviation did not change. Okay, I hope this was helpful.